So we are still on performance optimization and security. Previous class we looked at asynchronous code, database queries optimization, optimized libraries, memory management, compression, profiling, and monitoring and logging. So today we're looking at optimization techniques 2, which will look at using streams, caching, minification and bundling, and last but not the least, load balancing. Wow, wow, wow. This is great. So I'll just briefly talk about using streams, and will not be writing code on this using streams here. I'll just briefly talk about it, how it's useful, how you can apply it in your application. If you have if you have a large amount of data, you don't want to write that data to disk once, or you don't want to like send it to the client once. You want to send it in chunks. The data will be sent in chunks so as to optimize your application. In a situation where you send a large amount of data once, your application may crash or something like that. So you will have to use streams to send the data in chunks. And the reason why we're not going to be giving any examples is because we already treated streams and we see how this can be done. We even built a Node application without using Express, and I feel we are good with using streams and events. We combine streams and events, so I think we're okay with that. So the next on the list is caching. Wow. Okay, I think I prepared some notes, so just go over here. To repos, then KodeCamp Task Manager, then in the docs, and inside the docs we have caching MD. And in here we have what exactly is caching? Caching is the process of storing frequently accessed data or responses in a temporary storage location, such as memory or disk, to serve it to serve it more quickly when requested again. Like this can include various types of data like HTML pages, images, database query results, or even API responses. So caching helps reduce the workload on the server and decreases response times, ultimately improving the overall user experience. So below are some key points about caching in Express.js application. Like response caching. In the context of an Express app, you can catch HTTP responses. For example, when a client requests a particular resource, the server can store the response in memory or on disk. Subsequent requests for the same resource can then be served directly from the cache, avoiding the need to recompute the response. So we have the cache control header. You can control caching behavior using the cache control HTTP header. This header provides directives that specify how long a response can be cached, whether it can be cached at all, and under what condition it should be revalidated or fetched from the server again. Then the middleware. Express middleware can be used to implement caching. For example, you can create a middleware that checks if a request response is already in the cache, and if so, it serves it directly. If not, it lets the request proceed to the route handler, and the response is then stored in the cache for future use. Then optimizing an Express app with caching. Caching can optimize your Express app in several ways. Number one, improved response time. By serving cache responses, your app can respond much faster to client requests. This is particularly beneficial for frequently accessed resources. Then number two, it reduces server load. Caching offloads the server by reducing the need to regenerate the same responses repeatedly. This is especially helpful when dealing with resource-intensive operations. And when you have a whole lot of traffic, this is very, very useful. Bandwidth savings, like caching minimizes the amount of data sent over the network, which conserves bandwidth and then can lead to cost savings in situations where data transfer is charged. Yes. It enhances scalability. That's number 4. Caching can improve the scalability of your Express app. With cached responses, your server can handle more concurrent requests without a significant performance drop. So this is great. And if you really want to catch up, we have 2 options. That is the Node Cache and Redis. You can actually use Node Cache in production, and you can also use Redis. But most people prefer Redis, but we're not going to be using Redis in this our example here. But Redis is much more thin. You can just head over to their official website and check out their documentation. It's very simple to use. You can install Redis on your local machine and set up Redis. It's always running on port 6739 or 6739 also. So you create a client and then you can set expressions or set whatever you want to use Redis for. But in this example, we're using Node Cache npm. I think we have Node Cache here, published 3 years ago. I think that was when it was updated, and it has 2,770,071 weekly downloads. So the homepage here is on GitHub. Let's check it out. It's actually open source, Node Cache, simple and fast NodeJs internal caching. A simple caching module that has set, get, and delete methods and works a little bit like memcache. Keys can have timeouts, that is TTL, after which they expire and are deleted from the cache. All keys are stored in a single object, so the practical limit is at around 1 M keys. That's 1 million keys or so. The breaking major releases, version 5 and version 6 upcoming. So if you want to install Node Cache to do something, let's copy this and just paste it in our application. Paste it here. npm install Node Cache. That's I said. We don't need to save it. And then what we're going to do is we want this to be globally implemented in our application. So our next promotional task is going to be very challenging, but not that challenging, sure. But we'll leave some things for you to do. So what we're going to do now is we go to our library folder here. We already have Prisma.js. Then we create Cache.js like this. Then we'll import Node Cache from Node Cache. You see, const cache is equal to new node cache, like this. And it's a constructor requesting for options, but we don't have any options. You can leave it as undefined. And you see export cache like this. Okay. So we've implemented our cache here. Now it's time for us to use our cache. So we'll come back to our controllers task like this. Yes. So in here, we want to cache our tasks. So what I will do is I will implement it for one of the controllers on the get tasks. And then I will leave it to you later on. Okay. Now, let's just go ahead. Let me just not say it so that you go and prepare for it. Let's just implement it for this. Then later on, I'll tell you how to make a general function that will support catching all of our responses, both the get task, create task, and edit task, delete task, and all of that. Okay, so what we want to do is we want to import the cache. Let's first of all import cache. Where is it? catch. Okay. From lib/catch.js like this. Okay, so we've imported it. So we need a catch key. Now create it here. We say const catch key is equal to, let's see, KCTM. We'll do something like request URL. What we prefix every request URL with KCTM. If it gets tasks, we do something like this. If it is get task, is /ID, so it will be KCTM/request URL and all of that. So we prefix it with the catch key. Then we want to catch our tags now. Okay, so now let's come down here. We've already imported our catch. You say catch. Sorry, like this catch set catch.set. For sending our response, we want to catch this, and this function expects a key, a value, and a TTL. That's the time the catch should be valid. So the key is the catch key. And what next do we need? We need a value. Catch key, value, and TTL. Okay. Catch key. The value is tasks. Let's say 1 hour. Time to live in seconds. 1 hour, that's 60 times 60. 60 seconds in a minute and 60 minutes in an hour. 60 times 60, actually 1 hour. Okay. So as you can see, the time to live in seconds. So the catch will be available in 1 hour and then it will be revalidated. Okay. So it depends on your use case. If you have an app that users access frequently, adding and deleting data, you don't want your cache to be valid for an hour, or let's say 10 minutes, 30 minutes or so, your cache will be automatically revalidated so that it will not be out of sync with your database. It should be in sync with your database always. So that is one of the reasons why you should have to revalidate your cache frequently. So now, let's say result equal to this. Then we see if result is exactly equal to undefined, they want to log something like cache list like this. Okay, let's clear our terminal, and I think we run our 7 p.m. run dev. Then we check out Postman, add a request of local. Let's add the sign in and come here and then add local task. Then here we'll go to the body raw JC. We'll do something like username, the same one we've been using, and password like so. No, we don't want to save it. Let's make this request. This is a post request. Let's sign in. Okay, we've logged in. Let's get some tasks. Let's check our console. And it's like our cache is, there's something inside. Okay, what we will do now is we will log the whole cache. Let's make the request once more. Okay, this is the key, the time, and the value. The value is actually an array. Hit 0, misses 0, key is 1, key size 9, the value size is 40, string number, valid key types, the key can be a string or a number. So in our case, the key is a string, destroyed false. And then every other thing about our catch is here. The data KCTM slash, this is the key, and this is the valid time, and this is the value of our catch. What else do we need to see here? We have the mem sets, the sets, and everything about our catch. Okay, that's great. We've seen how that is. Now, anytime we miss our catch, we see this on the console, because sometimes we likely miss it. But that doesn't happen often. So let's see. It's working as expected. As you can see, this request is still taking time because we are still fetching. Every time we make a request, we are still fetching our data from the database, and it's still taking time. 499 milliseconds. Let's make the request once more. 481 milliseconds. Okay, so now we need a middleware that will check, and if there's anything inside, it will just return it rather than going to the database to make that same request. Okay, so now we'll make a catch middleware. So this middleware will take a request, a response, and the next function. So if there's nothing in our catch, it will proceed to the next middleware, and which is the get tasks. In this case, it will proceed to the get task and then fetch the task from the database. But if there is anything in our catch, it will simply return it, rather than making network requests to our database to return some data. So now let's create this middleware. Let's go to right here and create check catch.js middleware. We import from live/js like this. Then we'll create a function check catch. It will take in a request, response, and next. We kindly come down here and export check catch like this. Okay, so this is our middleware. So back to our controllers, and you have to make this general so that you can use your catch key anywhere. Let's copy our catch key here and bring it down to this place like this, so that it will be the same. If the catch want to check for data, to use this key. Oh, this is the key. Let me check now. Okay, so now we have our catch key, and we need to get the data. So if we want to get the data, we simply use the catch key to get the data. So what we use const data is equal to catch get. As you can see, it's the catch key. It's requesting get the catch key and change the stats. Okay, return the value stored in the key. So our catch is the catch key, the one we use in storing our tasks. So now we have our data, but what then do we want to do next? Let's first of all log our data. Let's make this request once more and see if we've got some data in our cache. Okay, we'll see nothing because we've not added this cache in the route. Let's come to the route here and add this check like this. So let's make the request once more. Make the request. Let's see. Undefined. Cancel. The cache is returning undefined. Let us go to cache get key. Okay. Let's make it once more. Cancel, and let's check our terminal. It's still returning undefined. Okay. Let's check our tasks to see if we've correctly implemented this. Yes, because we're going to cache set right key one. Okay, let's first of all finish the implementation. So we come here and say if data is totally equal to undefined, we want to return next. That's want to proceed to the next middleware in this route. But if there's data, we want to return the data. And this is a method here. But this time around, oops. This time around, the tasks will be the data from the cache like this. Okay. So let's make this request once more. We're still getting undefined. Controllers tasks. Okay, if result is equal to undefined, cache key tasks. Okay, cache key is a string. Okay. Let's check our middleware once more. Response status, request response next. Request URL, if data is equal to undefined. Return next. Yes, return rest status. Okay, JSON task data error no. Okay, so what do we have here in our route? Get session notes, cache, check cache, get tasks. The check cache is coming from the check cache. Yes. Okay, so let me restart this and see. Why we are not. Okay, we're still getting undefined. So why is that so? Okay, set cache key. You know what? Let's log our cache once more and see what you got. Okay, if equal to result. Okay, let's log our result and see what we've got first. I think it's time to debug unauthorized. So we'll sign in. Sign in. We're logged out, so we'll log in again. We're logged in now. We'll send. Let's check our terminal. It's returning true. That means we have something in our cache. But then when it comes to the check cache here, request if data is equal to undefined, we're logging data and we're getting undefined. Okay, so what's the problem here? Data is equal to cache get cache key. Our implementation in the task here is correct because this is true. If it's not true, that means it will return undefined, and then we will get cached miss on the console. But then in our check cache here, I think there's a little kind of a mistake. I don't really understand what it seems to be. Cache key. I think this is the cache, the same cache key we're using here. Let me just copy it once more and paste. Okay, so let's just log the cache entirely to see what is inside. Okay, so we have okay, the key size 0, the value size is 0, miss is 1, okay, hit 0. Wow. Let's try it again and see how many misses. Internet server error. Key is 1. Okay. True. Key 0, key size 0. I think our second request, we got key size of 9 and the value size of 40 after we missed. So what actually is happening here? Or is this, I don't think, is it, I was supposed to make the second class? Okay, let's do it once more and see. We're still missing. So, okay, let's log data. We are missing and data is returning undefined. Just see returning undefined, and the result is returning true because there's something in our cache. But then why are we not? Okay. Let me quickly look out. Okay. Where is it? Where is it? Node catch 5.1.12. Okay. And let's come back to okay. We're here, the node catch. New node catch. Key value TTL. Set object. If it returns true, if you want to set an array, okay. Okay, if value is undefined, I think this is, I'm using triple equals, and this is double equals here. It's a mistake from me, or I don't think there should be any difference using triple and double equals. In this case, I'm still getting undefined. Okay, I think the mistake is from us, but I can't seem to see where. Return status is seen. There's no need for an await here because this is not synchronous. And let me log cache key. So cache key. And this is our cache key, and the data is undefined. Wow. Okay. Let me place it over here and see. Well, it's not supposed to be like this. It was supposed to be authenticated before trying to access our cache. Wow. So right now, we seem not to be getting any results. Check cache. Wow. And this is JavaScript. I think we wasted a lot of time debugging this because there's something in our cache, but then in our cache. I'm trying to know exactly the problem is from. We're getting the same result. Okay, let's come to this index.js. I think just this one. Send the request once unauthorized. Let's log in. Send the request. We've gotten our results. We're getting undefined. I think the problem is not from here. But what? Okay, let's try another trick. Let's come down to this place and quickly create a function here of check. Let's say check to take a request, a response, and the next function. And we check const data is equal to catch key. We'll quickly copy it here and paste it here. Let's log data. Check. Let's pass in our middleware to get tasks. Make this request once more. And check if there's any response. Still undefined. Let's try another way. Let's see, the catch key here is test. And the one here is also test. Where is it? This. Then start our server and make this request once more. Cancel it. Check out terminal. Still returning undefined. Wow. Okay, so I think after the class, if we still have time, we will debug this. Or simply we were supposed to get our results, and I don't know what the problem is. This set function is correct. We actually have things in our cache, but then we can't get them, and I don't know the reason why. Cancel the requests and check undefined. Okay. So since the cache is giving us problem, we will move to the next item and then come back to check later on. I think the next item we have on our list here is minification and bundling. Okay, so we'll come here, come back to docs, and then we'll open minification and bundling at MD. So what is minification and bundling? So minification is a process in which the size of JavaScript or CSS file is reduced by removing unnecessary characters, such as white space, comments, and sometimes renaming variables. The primary goal of minification is to make the code more compact, which leads to faster downloads and improved website performance. Minified code is more efficient for transmission over the internet because it reduces the file size, resulting in quicker load times for web pages. And below is some details about minification. There's white space remover. Minification removes spaces, line breaks, and indentation that are not required for code execution. And variable shortening. Some minifiers also replace variables names with shorter names. For example, long variable name might become A to save space. That's great. And in comment remover. Comments are often stripped from the code because they are for developers' understanding and not needed for the browser. Sorry, by the browser. And bundling. What is bundling? Bundling is the process of combining multiple JavaScript or CSS files into a single file. This bundle file contains all the code needed for a web page or application to function. Bundling has several advantages. Reduce HTTP requests. Instead of making multiple requests for individual files, a single bundle file reduces the number of HTTP requests. This is crucial for improving page load speed. Improved caching. Browsers can cache a single bundle file more efficiently. When users revisit a page, their browser only needs to download the updated bundle if changes have occurred. Then simplified maintenance. Managing one or a few bundles is easier than handling many individual files, making code maintenance more straightforward. Okay, so how can we actually implement bundling in an Express app? This is a package here which is ESBuild. We'll be using ESBuild to do this. ESBuild. Here is ESBuild. Let's get started. You can save npm install save exat save dev ESBuild. We'll install it as a development dependency. So what we will do here, we'll simply copy ESBuild and install it in our application. Okay, so this package has some flags. So let's move to, I think there's something here. We'll see content JavaScript, TypeScript. I'll come to, it should be let's scroll down. Yes, there would be a build script. We'll add, look at ESBuild app.js. That is the root of the project you want to start bundling from. So we want to start with our index.js here. In this case, it's app.js. Then we'll bundle it, and the output file is out.js. But in our case, let's come here, and then if you run npm run build, then everything will be built. In our case, what we will do is we want to create a build folder. Let's create a build folder here. And inside of our build folder, we want to actually bundle our app, but we are not targeting the browser, we're targeting Node. So what we do is we come to our package.json and we add one more script. We have start dev and we add build, add a comma. We have ESBuild, and then we want to start from our source/index.js. We'll bundle it. Remember what bundling is: minification and bundling. One is the process of combining multiple JavaScript CSS into a single file. So we want to bundle it. Okay, let's go back to our VS Code. And we want to bundle it. And the platform we're targeting is not the browser, but Node. We're targeting Node. I can even specify the version of Node you are targeting. And let's say we want to target Node 18, Node version 18. And the output file, we want it to be in the build directory. And the name should be app.js. Okay, ES build. We want our ES build to build this for us. We want to start building from the index.js and want to bundle it. We are targeting the platform node. We're not targeting the browser. And the node version should be node version 18. We're targeting node version 18. And the output file is equal to build up. Okay, let's target node version 10. Version 18. Let's leave it like this. So if you come down here and run npm run build. Wow. You see this build/app.js, and the size of the file is 4.2 MB, done in 346 milliseconds. So this is what, and let me explain why this is. When you deploy your, let's for instance, we've been deploying our application to Cyclic. So once we deploy our application to Cyclic, this is actually what Cyclic does. It will build this application before deploying it. It will build it and it will deploy this, only this file. The rest of the things we have in our application doesn't matter. And this is the build version. Look at our use script, create object, define property, and all of that. And there's a comment, if the importer is in node compatibility or no, this is not an ASM file that has been converted to CommonJS file using a Babel compatible transform. There's that. Okay. This is our build file. Everything is in here. Our CSS, our JavaScript, our HTML, everything is inside here. And if you scroll down, you will see we have a bunch of things. All our libraries have been bundled. We have everything in here. Everything is in here. Compressible index.js, compression index.js. We have our basic auths, unfinished index.js, Morgan index.js, bcrypt. This is the license, Prisma. Everything is being bundled. So we have this, just this single file, and this is the whole of our application that we'll be running in production. This is the only thing that we run in production. Every other thing doesn't matter. It only matters for developers. So this will run in production. So let's say we delete the build. You can delete it anytime and rebuild the application. Run it again. And our build folder will be automatically created with this app.js inside. Can you see? Everything it has rebuilt. If you go up, you see the same thing. Like so, use strict and everything. Okay, so when it comes to CI/CD, continuous integration and continuous deployment, this is very, very important, because when you, in our next class, we'll be looking at CI/CD with GitHub Actions, and we can see how we not allow, how if you don't want your platform where you're hosting your application to do this for you, you actually build it by yourself and then deploy it automatically. We can actually take this and deploy it on any hosting service and it will work without allowing it to build it for us. We will deploy it manually and it will actually work. So if you don't want this build, we don't need it in /build like this. We don't need it. So anytime we push this to GitHub, the build is not, because anytime you clone this, you simply install the dependencies and then you run npm run build, and this will still build for you. And we're targeting Node. Anytime you want to change the version of Node, you can even remove this. You don't want to target Node 18. You should just use Node and then build this. It will automatically set the Node version for you. So the output file build app.js, a bundle, and this is actually how to bundle an Express app. And we have our file. This is what is running in production, not all this. We don't have the node modules here. We have a millions of files and folders in our node modules, and it will only bundle what is required. It will only extract what is required and then bundle it in production. As you can see, the file size is very, very minimal, 4.2 MB. But if you want to like bundle everything here, only node modules is about 500, 800, 1 gigabyte. So this is actually great. We've bundled our file, and this is the usefulness of minification and bundling. And before bundling, you can see that there are no comments. Every comment we added, there's no comment here. This comment, they've added it for their for quite a good use, and this code has been converted to older JavaScript versions. for cross-platform usage, so that older browsers can understand and new browsers can also understand. Okay, so that is actually sweet. And you can actually always come back and read about minification and bundling. It's very, very important. And some of the code bases, sometimes you may like to view a code base or explore a code base that has already been bundled, and you see that, oh, you don't understand this. Is this really JavaScript? So this is actually what is going on. It has been bundled, and it will be hard for you to understand. It is bundled for production, so there's no need going over that kind of code. Okay, so I think that's it for minification and bundling. We've learned how to minify and bundle our Express application, and we can take that, verify, and execute it, or deploy it directly to any hosting service. And now, wow, this is it, load balancing. You know, there are many ways we can do this, but I want to show you, I want to take you the hard way. I want to really teach you that with this, I want to teach you some things. I want to expose you to something, some things you really need to understand. Things like virtual machines, the difference between a virtual machine and a container, the Vagrant, the virtual box, and all of that. So I want you to get exposed to all these things, so that when you come across them, you will be able to like handle them effectively. Okay, so let's jump. This is going to take much more of our time, but I will leave some things to you so you can go do them by yourself. So let's first of all visit our docs. We'll visit our docs here. As you can see, we have load balancing here, MD, and we have VirtualBox. So before we jump into load balancing, I want us to, let's view the VirtualBox. And inside of this VirtualBox, the title here is VMs, that is virtual machines. And we have the subtitle here of hypervisors. So hypervisors, okay? Hypervisors, also known as virtual machine monitors. Hypervisors are also virtual machine monitors. Always remember this. And are fundamental components of virtualization technology. They are software or hardware platforms that enable the creation of management and virtual machines on a physical host machine. Hypervisors provide an abstraction layer that allows multiple virtual machines to run concurrently on the same physical hardware, isolating them from one another. So there are two primary types of hypervisors. You need to come back to this thing, read it, and make your own research. Because as a back-end developer, you are more close to DevOps engineers than the front-end developers. So you have to understand all of this, so that in case a DevOps engineer is having an issue, or you are even in charge, you can take care of all this. So we have type 1 hypervisor, which is also known as bare metal hypervisor. So type 1 hypervisors run directly on the physical hardware. That is the bare metal. That's the reason why it is known as the bare metal hypervisor. It runs directly on the physical hardware of the machine, of the host machine. So they do not require a host operating system. Instead, they act as the operating system themselves. They do not require a host operating system. Instead, they act as the operating systems themselves. So type 1 and hypervisors are typically used in enterprise data centers and cloud environments. Examples of type 1 hypervisors include VMware, vSphere like EXXI, Microsoft's Hyper-V, and Xen. So we have the type 2 hypervisor, which is hosted hypervisor. And this is the one we're going to be using to learn about load balancers. So the type 2 hypervisors, hosted hypervisor, the type 2 hypervisors run on top of a host operating system, just like other software applications. And you will see that in a minute. They are often used for development and testing environments on desktop or laptop computers. Type 2 hypervisors are less efficient than type 1 hypervisors because they run on top of another operating system layer. Example of type 2 hypervisors include Oracle VirtualBox and VM Workstation. Actually, I'm using Oracle VirtualBox on my system, and you'll see that in a minute. So the key functions of and characteristics of hypervisors include isolation. Hypervisors create isolated environments for VMs, ensuring that one VM's activity does not affect the others. Isolation is a crucial aspect of an aspect of security and stability. Then resource management. Hypervisors allocate and manage physical resources, the CPU, memory, storage among virtual machines. They ensure fair resource sharing and can impose limits or priorities. And I will show you that in a minute. Hardware virtualization. Hypervisors interact with the hardware of the most machine to virtualize it, making it appear as though each VM has direct access to the underlying physical resources. Then snapshotting and cloning. Hypervisors often support the ability to take snapshots of VMs at specific points in time. These snapshots can be used for backup, recovery, or creating cloned copies of virtual machines. Then the live migration. Live migrations in many enterprise level hypervisors, VMs can be moved from one physical host to another with minimal downtime. This is useful for load balancing, maintenance, and disaster recovery. The compatibility and portability. VMs created on one hypervisor can often be migrated to another compatible hypervisor, making it easier to move VMs between environments. And this is awesome. And this may sound like a language you don't understand, but then come back to this, take your time, go through it, and then make sure you understand, because before going into load balancing, we're going to balance the load on our server with Nginx. And the reason why I'm showing you this, I want to show you something very important, how you can isolate your development environment from your own physical computer without using Docker, because Docker is a container, and we'll see how virtual machines differs from containers in a minute. So a VirtualBox is an open source virtualization software that allows you. Now we're looking at VirtualBox. We are done with hypervisors, because I want you to understand what hypervisors are, so that you understand better what VirtualBox is, what a VirtualBox is. So a VirtualBox is an open source virtualization software that allows you to create and run virtual machines on your computer. And it was originally developed by Innotech GmbH and later acquired by Oracle Corporations. And Oracle are actually maintaining it now. That's the reason why you saw something here like Oracle VirtualBox, because they are the maintainer of the VirtualBox, and it's actually open source. VirtualBox is a powerful and versatile tool that's widely used for various purposes, including software development, testing, and running multiple operating systems on a single physical machine. And in just a minute, you will see how I'm running at the Ubuntu operating system on top of Mac OS. The Ubuntu is a Linux-like operating system. It has actually two versions: the one with the graphical user interface, and the one without this GUI that you can only manipulate and then interact with it using the command line. And we're going to be seeing that in just a minute. Okay, so here are some key points about VirtualBox virtualization. VirtualBox is a type 2 hypervisor, which means it runs on top of an existing host operating system. In this case, I'm running it on top of the Mac OS, on top of the Mac operating system. So it allows you to create and manage virtual machines that can run different operating systems, known as guests, simultaneously on a single physical computer, known as the host. Now, number 2, cross-platform. A VirtualBox is available for multiple host operating systems, including Windows, macOS, Linux, and others. This means you can use it on various platforms to run guest operating systems of your choice. In this case, the host is the Mac operating system, and the guest is the Ubuntu that I'm running in the VirtualBox inside Vagrant. And we'll see what Vagrant is in a minute. Just pay attention, make sure you come back to this, read and understand. The guest operating system. VirtualBox supports a wide range of guest operating systems, including Windows, Linux, macOS, FreeBSD, and more. It allows you to run different versions of the same operating system concurrently. Snapshotting. And VirtualBox provides the ability to take snapshots of virtual machines at various points in time. Snapshot allows you to save the VM's current state and revert to it later, which is useful for testing, development, and system recovery. And then cloning, networking, USB support, extension pack, API, command line interface, and then open source. Okay, so at least we've known what a VirtualBox is. It's a type 2 hypervisor, which means it runs on top of an existing host operating system. It allows you to create and manage virtual machines that can run different operating systems. You already know what a hypervisor is, and we know type 1 and type 2. So this is a type 2 hypervisor. It runs on top of a host. In this case, mine is running on top of the Mac operating system. And the guest is the Ubuntu operating system, and we'll see that in a minute. So we have Vagrant. What exactly is Vagrant? Vagrant is an open source tool for building and managing virtualized development environment. It simplifies the process of setting up and configuring virtual machines to create reproducible and consistent development environment for software development and testing. So actually, Vagrant is particularly popular among developers and system administrators for a variety of reasons. Reproducibility, portability, isolation, support for multiple providers, provisioning. And let's just, Vagrant makes it easy to automate the setup and provisioning of VMs. You can use configuration management tools like Ansible, Chef, or Puppet to automate software installations, configurations, and other tasks within the VM. And this may sound new to you, but I recommend you check out Ansible or Puppet because those are the most popular. Puppet, in fact, Puppet, people have been using Puppet to automate some tasks. And you check that out. Maybe you will get some knowledge, and believe me, you get to love it because you need to know what is happening. And then the number one, reproducibility. Vagrant allows you to define your development environment as code using a configuration file, typically written in Ruby, known as the Vagrant file. This file specifies the base box, that is the VM template, provisioning scripts, networking settings, and more. This makes it easy to share the configuration with other team members and ensure that everyone's environment is consistent. And portability. Then you just come back to this and make sure you read and understand all of this. Okay, so in review, Vagrant is particularly useful for development and testing tasks, allowing developers to create this visible development environment that mirrors production systems. And overall, Vagrant simplifies the process of managing virtualized development environments, making it easier to create and maintain consistent and reproducible development setups. So you may be asking, what is the difference between virtual machines and containers? So I took my time out to curate this content so that we actually understand the difference between virtual machines and containers. Containers are virtual machines are both technologies used for virtualization. Yes, they are both used for virtualization, but they have distinct differences in terms of architecture, resource utilization, and use cases. So here's a comparison of the two. The architecture, the reason why I'm doing this is I'm taking you close to DevOps. I'm trying to get you close to DevOps. So we always avoid this DevOps thing, development and operation, and it's very, very important. It is very, very, very important. So I want to take you close to DevOps because I love DevOps, and DevOps is very, very, it's not a job. It's not a job title. It's not a lifestyle. DevOps, it's okay. It's actually a lifestyle, or it's a kind of, DevOps is unique. Let me just see. Okay, in terms of architecture, let's say in a virtual machines are they are full virtualizations that they run on a hypervisor, which is a software or hardware layer that emulates the physical hardware. So each VM includes its own full operating system, the kernel and user space processes. This means VMs are relatively heavyweight in terms of resource usage, and that's true. But when it comes to containers, containers are lightweight virtualization. They share the host OS kernel and run as isolated user space processes. Containers don't include a full operating system. Instead, they package the application and its dependencies into a single unit. This makes containers more lightweight compared to virtual machines. Okay, and there if you don't know Docker, you get to, oh, so Docker is a container, and this is what Docker does. This is what a virtual machine does. So your resource utilization. VMs are resource intensive. They require more memory and storage because they run a full operating system. VMs are less efficient in terms of resource utilization. Containers are highly efficient with resource because they share the host operating system kernel. They use less memory and storage, and you can run many containers on a single host without significant overhead. In isolation, VMs provide strong isolation because each VM has its own operating system. This isolation is beneficial when it comes to the containers provide lightweight isolation. They share the same OS kernel, which can result in slightly weaker isolation compared to VMs. However, containers can still offer strong isolation when used correctly and are well suited for many use cases. Then portability, startup time. Virtual machines generally have longer startup times, and containers start instantly because they don't need to boot an operating system, and that's correct. Overhead use cases, and then VMs are well suited for scenarios where strong isolation is required, or when you need to run different operating system versions or have specific hardware requirements. They are commonly used in traditional virtualization environments. The containers are ideal for microservices architectures, continuous integration, and continuous development, cloud native applications, and scenarios where efficiency, scalability, and portability are crucial. They have become popular in modern software development and deployment, like Docker and the rest. Okay, and I think Docker is the most popular one. So now we've known what VMs, virtual machines are, what hypervisors are, what a VirtualBox is, a type 2 hypervisor, and what Vagrant is. You need to pay attention to this Vagrant, or open source tool for building and managing virtualized development and development environment. Let's move to load balancing. Okay, so what is load balancing? Load balancing is the process of efficiently distributing incoming network traffic, such as web requests or data queries, among multiple backend servers or resources. It is typically achieved through a load balancer, which acts as an intermediary between clients, e.g. user web browsers, and the servers that host the application or service. The load balancer makes decisions about where to route each incoming request based on various algorithms and server health checks. Usefulness of load balancing: we have improved performance, enhanced reliability, scalability, session persistence, and security. And in our load balancing, we're using Nginx, pronounced as Nginx. Nginx, pronounced as Nginx. It's a popular and high-performance open-source web server, reverse proxy server, and a load balancer. It's known for its speed, efficiency, and versatility, and all of that. So as a web server, Nginx can function as a standalone web server. It is designed to serve web content such as this, that, and that. Okay, that's it. But as a load balancer, Nginx can function as a load balancer, distributing incoming network traffic across multiple backend servers. It uses various load balancing algorithms to ensure even distribution, enhance performance, and provide redundancy in case one server fails. Okay, so this is great. And I actually provided a rough configuration of Nginx, which I've already done. And now I want to start up a virtual machine. So let me open my terminal here. I think like this. Okay, let me zoom in. Okay, like this. Okay. So I'm using Vagrant, and I have VirtualBox. So I will just say Vagrant up. I think the Vagrant is already up. So if it's up, it will tell me that it's already bringing machine diff up with VirtualBox provider. Checking if Ubuntu 4.0 version 2.2.2 is up to date. Machine is already provisioned. Run Vagrant provision or use the provision. Okay. So now we run Vagrant SSH. And as you can see, now we are no longer running the Mac operating system. We are on Ubuntu, the Ubuntu operating system, and we are on the Ubuntu 4.0, which is version 20. The Ubuntu 4.0 version 20. And if you do ls, we have project folder. Let's cd into our project folder. The ls, we have nothing inside of this. Okay, so now I want to open another terminal window. And what I want to do is ls, we have a Vagrant file. So I want to take my time and explain this Vagrant file. We do code Vagrant file. Okay, and we have our Vagrant file open here. So vagrant configure 2, this is the configuration of the vagrant. And it's written in Ruby. Set F, it's Ruby mode, Ruby, and all of that. It's written in Ruby. So config virtual machine that box is Ubuntu/vocal64. And you can use Windows, you can use any operating system, but in here we are using Ubuntu that is vocal64, which is the version 20 of the Ubuntu operating system. And then they have done the necessary configurations. We've configured the VM. And if you want to configure this like this, if you want to immediately after installing VirtualBox and Vagrant, if you want to initialize Vagrant, you say Vagrant init, and then it's either you provide the Ubuntu/vocal64, or after initializing Vagrant, it will create this file in the root here, where you can see it, this Vagrant file. Then you open it up. After opening it, you can see, then you see this, it will not automatically, it will not be vocal64, but you can change it /vocal64 and then try to run Vagrant up. And this will automatically install and then change it to vocal64. Then you come down here, you change this. In our Ubuntu operating system, every service will be running on port 8080. But then what we want to do is we want to forward this port to the Mac operating system. We want to forward it to the host. This is the guest, and the guest is the Ubuntu operating system, which will be running on port 80. Then when we forward anything that is running in Ubuntu operating system on port 80, when we forward it to the Mac operating system, we want it to run on port 8080 in the host, which is the Mac operating system. Then the host IP address is the host, that is the host IP address, should be this is the local host, and the host name should be localhost. You can actually remove the host name and leave it here, or you can actually change this to any host you want it to run. So this is a necessary configuration we need to run our load balancer. Okay, so that is the basic. You can go and learn more about the Vagrant and Vagrant file and what it entails. You can actually go learn how to install VirtualBox if you're using a Windows system or Mac. It's very, very simple how to configure Vagrant. So inside of Vagrant, there's this text editor that's automatically installed, which is the VI text editor, or the Vim. That is the super version of VI, the Vim text editor. So it doesn't work like VS Code or other, but it's very, very, very powerful. And you can configure it to work like VS Code and other text editors. Actually, I've not configured mine since I changed my machine, but basically we can use it like that. Though it is a little bit, but we can go ahead and then use it like that. So what we do now is we create a server. Let's create, let's cd our server. Then here you say npm. I've already installed Node in the Ubuntu operating system. I've installed Node, and I've installed, when you install Node, it will come with npm. So we'll say npm init-y. And then we have our package JSON file. So we'll say vim package JSON. And then our package JSON is open. This is our text editor. And then we come down here and we say, okay, so we want the type here to be, type to be module like this. And I think that's all. Okay. Then we'll write and quit. If you don't want to write and quit at the same time, you just look at the bottom left corner of my bottom corner of my screen. We have write and quit. But if you don't want to write and quit at the same time, if I press enter now, it will save this file and quit, and the text editor will exit. But if I say write now, write, then package JSON, I've written 240 bytes inside the package JSON. Then if I go with quit, now I've written and saved the file, then I will quit. So my package JSON is now updated. So now we say npm I express. Okay, we've installed Express, then npm i-g as a development dependency node mon. So now what we want to do is to open up, let's open up package.json once more, and then we'll add a start script here. So start, then we see node mon index.js like this. Then we'll add a comma. Then we write and quit. So to clear our terminal, then let's create, we can actually create this file automatically by saying vim index.js. The file does not exist, but when we say vim index.js, it will automatically be created and opened in the text editor. We hit enter, and here we have our file. We say import express from express. Then we say const app is equal to express. Then we say const port is equal to process env port. And you see how we're going to be using this port in a short while. Okay. Then we see app gets the index route like this. Let's open this. I want to see const message is equal to template strings, template trace. I will say server running on, let's interpolate this, server running on port like this. Okay, then we say response send message. Great. Okay, so I think that's all for that. Then we'll come down here and see app listen port. It will take a callback with console.log another template, which I don't say server running on port, interpolate it port like this. So this is great, and I think this is all we have to do here. Then we write and quit. Okay, so now let's say export is equal to 3000. Then we say in npm run dev. Is this start or npm run start? Okay, okay. Now we automatically set our port for 3000. Let's stop this and then open our nginx configuration file /nginx/nginx.config.conf. Okay, so I already made some minor changes here. Okay, one is changing a read-only file. Okay, what we do is we close this file and reopen it. Now we open it as the user we'll use sudo vim /etc/nginx/nginx config like this. Okay, so now we can edit it and save it with no errors. So this is our nginx file, but first of all, server here. and write a slash. Okay. This is basically our Nginx file. This is a minimal setup, but we have two server instances running on server localhost 3000 and localhost 4000. Though we have not implemented the second server, but what we want to do is we'll start our server in two instances of our server. One will be running on 3000 and one will be running on 4000. But our main load balancer will be listening to changes on this file. It will listen to this server here, which is our server that we've created and we've implemented. So when we start our server on localhost 3000, another on localhost 4000, any changes in this server, it will capture these changes and then forward it to server 1, capture it and forward it to server 2, and then it will I think it will balance the load. If a first request is sent, it will send it to server 1, second request sent to server 2, and if you have like 20,000 requests, that is 10,000 will go to server 1 and 10,000 will go to server 2. You can remove this local host and change it to IP addresses like 127.0.0.1, then colon 3000 and so. But what we want to do here, and as you can see, we have server localhost 3000. This is proxy upstream backend. So let's look at actually what this thing means. Let's come back here. This is the complete structure of our Nginx configuration. So I try to break this down so we can understand what is going on. So our Nginx configuration file, is divided into different sections, each with its specific purpose. Let's go through this line by line. So we have the first one, the HTTP directive. This line starts the HTTP block in Nginx. The HTTP block is the top-level configuration block for HTTP related settings. It contains global settings for the HTTP server, including how to handle incoming requests and where to route them. Then the next block is the upstream backend. Backend takes server, first server, the second server, and we can even pass in a third server, and we do that in just a minute. So upstream backend, this defines an upstream group named backend. An upstream group is a set of, you can change this backend to any name you wish, but we've given it a back name because there are backend servers. An upstream group is a set of backend servers that Nginx can proxy request to. That is, it can forward requests to. That is just the simple meaning of proxy request to. In this case, it defines two backend servers running on localhost and listing on port 3000 and 4000. Request to this backend group will be load balance between these two servers. The next block is server listen 80. The server directive, this line starts a server block. A server block is used to define the settings for a particular virtual host or website. In this case, it specifies the configuration for requests to port 8080. And all our requests will be forwarded to port 8080, not port 3000 or 4000. All will be from the front end, we'll be forwarding all our requests to port 8080. When we listen to port 8080, this line specifies that the server should listen on port 8080. Port 80. Port 80 is the default HTTP port. An incoming HTTP request to this server will be processed. So the root, home background project, and alias specify server root. This actually because this line sets the document root for the server. So the root directive specifies the directive where Nginx will look for web contents. In this case, it's set to this, meaning that Nginx will serve files from this directory when handling requests. After it's handled the incoming request, it will distribute it to localhost 3000 and then it will serve back the files from this. Then location. This line defines a location block within the server block. Location blocks allow you to specify how Nginx should handle requests that match a particular URL path or pattern. In this case, the location block matches requests to the root of the website, your server. So proxy pass, HTTP backend. Can you see the root of the website? Our servers, we have Nginx, we have two servers here. So Nginx will route this request to these servers. So the proxy passes with this line is part of the location block and specify that requests matching the location should be proxied to the backend upstream group defined earlier. It load balances the request between the two backend servers on localhost 3000 and localhost 4000. The event, this section is empty in the provided configuration. The event block is typically used to configure settings related to how Nginx handles system events, such as the number of local processes and connections. An empty event block means that the default setting will be used because this is a basic load balancer and we don't need to configure the events. In review Nginx, so you can go ahead and read that. But let's go back to our Nginx file. At least we've briefed how Nginx, this configuration file, what it means. Now the root, we are pointing to our folder here. This is where the files and everything will be served from. So the location is when this server port 8080 is listened to, the index, it will listen to this place. So proxy pass, this Nginx will now redirect this request to either server with port 3000 or port 4000. And you know what? Let's come again here and let's see, add another server, local host 5000, like so. Then what we want to do here is, as you can see, proxy pass http/backend. If you change this to, let's say servers, you will have to come here and change this to servers. So let's save this file. We want to reload Nginx. Then we'll say sudo privilege user privileges. We want to use sudo to enable user privileges. Then we'll say system ctl restart Nginx. And then we've restarted Nginx. So now let me show you something. Let's clear this. Let's come back here and load Node here in our browser and load localhost. It's not 3000. Localhost 8080. As you can see, 502 bad gateway. As you can see, we have Nginx 1.18 on Ubuntu operating system. It's not running on the Mac operating system. It's running actually on the Ubuntu operating system. So let's check this in the dev tools in the network tab. Let's go to network and then refresh this to make a network request. And then click on this. Then scroll down here. You see the server. Server is Nginx version 1.18.0 Ubuntu. Content length 568. Keep the connection is keep alive, and you can see the remote address is 127.0.0.18080. And if you check in the background file, that is actually the host IP, and the guest, it is running on port 80, but then this guest is forwarding this to the host, is forwarding it to port 8080 to the host, and that is why we're accessing it here. And if you run port localhost 80 here, you have nothing because it's not running on the Mac OS. The 80 is running in the Ubuntu operating system and it's forwarding here on port 80. So the reason why it's 503 bad gateways, it simply means the server is redirecting on, like, it's trying to run a server, trying to forward request to a server that is not running. So in this case, let's come back here quickly and then we'll distribute this. Start 3. Okay, let's start another one. Okay, let's say vagrant SSH here. Come here and say vagrant SSH as well. Then cd project/server. Come here and we'll cd, clear our terminal, cd project/server. And let's assume the Ubuntu operating system is our server in production. So we want to start this in multiple server environments. How many do we have? Okay, I think we should just close this for now. Okay, we have 3. Okay, so let's clear this. And then let's see export cat pot. No, what? Echo pot. Is echo pot. Okay, I think it's not this one. Yes, okay. Echo pot. Let's just start afresh. You see export is equal to 3000. Then we see npm run start. Great. Server running on port 3000. So let's come to the browser, then refresh. So rest is not defined. Okay, our application is running, but then we're getting an error. So let's use one of these and then edit it. Vim index.js. Yes, okay, that's true because we don't have rest in our function. We have request and response. And then notice how what will happen if I write and save. Then you can see that this server restarts automatically. That's great. So let's clear the terminal here. No, it's running. Sorry about that. It's running on port 3000. So let's clear this one and then come down here and refresh our browser. Okay. And if you keep refreshing, it's just server running on port 3000 because for now, Nginx is forwarding this request to only this server because the rest of the servers are down. So let's go ahead and start the rest of the servers. Export port equal to 4000. npm run start. Great. Server running on port 4000. Now come here and refresh. Refresh again. Refresh. Can you see? For 3000, 4000, 3000, 4000, 3000, 4000. Great. So we have two instances of our server running and Nginx is load balancing our application. If a request comes in, it will forward to this first server. And this is actually a layer 4 load balancer. A layer 4 load balancer. That is a transport layer. Layer 4 load balancer. And we have another type of balancer, the layer 7, which is the application layer load balancer. In this case, even if it is authentication, for 3000, another person will authenticate and it will forward it to support 4000. Just like that. If you implement a layer 7 load balancer, we can decide to say, if it is authentication, Nginx, forward this request to port 3000. And we can actually assign names to this port. You can say kctm.alt@kctm.com or like so. An introduction. Then we say if it is to fetch tasks, forward this to port 4000. If it is authentication, always forward it to port 3000. If it is to fetch tasks, if it's tasks, forward it to port. That is a layer 7 load balancer, the application layer. But this one we are implementing here is a layer 4 load balancing, much more like a reverse proxy. Sorry to say, a reverse proxy, where a client for the Nginx, we have to check the request if it is not malicious, and then decrypt the request, and then forward it to the server to reduce the server load. The server will process it, send back the request. Nginx will encrypt it and then send it back to the client. Okay, that is sweet. Then let's check our export port is equal to 5000, like this. Let me say npm run start. Now we have 3 servers running. So let's come back to our browser and then check this out. 3000, 4000, 5000, 3000, 4000, 5000. Wow. Can you see this? This is beautiful. Now, no matter the amount of load, we have 3 servers and a server can handle about 1000 requests per second. So we have 3000 requests per second. We have 3 servers that can handle 1000 requests per server. We have a number of 1000 requests per server. So this is just the introduction to And you can change the algorithms. You can go learn how to change algorithms and now notice something. Let me just stop the server here and then clear the terminal. And then let's come back here and we'll refresh. Can you see that? Now the layer 4, the server on port 5000 is down and our application is running very, very fine. Can you see the advantages of using load balancers? And in production, this is very, very important because when one server goes down, you use other servers. And this is very, very great. Then when you go into web architecture and web architecture, where we have, is it a kind of distributed web architecture and is it a single or a single monolithic web architecture, where you learn about a single web server with no load balancer, a single web server with one load balancer, and then two servers with different load balancers. And here you get to understand. And let me tell you something. We can actually forward this request. We can actually take a single request and forward it to a different load balancer again. We take it from this load balancer, forward it to a different load balancer that will distribute those requests to another, to different servers. And in this case, we can actually implement the authentication and our tasks API. We want it in such a way that if a request comes for authentication, we'll forward it to the authentication load balancer so that it will distribute it to the authentication servers that we have. And if we take the task request, we'll forward it to the task load balancer so that it will distribute it to the task load balancers that we have. So the task servers that we have. So load balancers work in different ways. So if you come here now, you refresh, server running on port 3000. This is a different server. Server on port 4000 is a different server altogether. Server on port 3000 is a different server altogether. Okay, let me zoom in so that you can see. Let's refresh server port 3000, port 4000. Now, if you decide to come back here, where is it? And then say export port equal to 7000. I will say npm run start. It is still our application, but then the server is not running on port 5000 anymore. It's running on port 7000. And if we decide to come back here and refresh, it should take a little while, but it will take effect. Okay. Oh, we don't have it in our NGX configuration file. We're supposed to add it in our NGX. Port 5000. npm run start. Okay, so now we can come back here and refresh, and then we have server running on 5000, running on 4000, 3000, 5000, 4000, and like that. So great, this is sweet. And then now, let's say we're serving to use ngrok. I call it ngrok. Is it ngrok or ngrok? To serve our application globally on our local machine. People can be able to navigate the application with no so let's stop this, and let's see which one is left. Port 3000. So let's come here, refresh, and then it automatically fall back to the port 3000, the one that is running. The rest are down. So if you refresh and refresh and refresh, the rest of the ports are down. I mean the servers. So if you come down here and then stop the server as well, and then come back here and refresh, 502 bad gateway nginx Ubuntu. That means there's no server running and you are trying to forward a request to a server that is not running. So that is actually sweet. So I think in review, we've touched using streams, minification and bundling, caching, and then load balancing. And I believe we've learned a whole lot today. So if you have any questions on trying to set up VirtualBox or Vagrant or Nginx completely, you can get back to me and I will So are there any questions? So we can come to the end of the class. Okay, so if no questions, let's call it a day and we'll see in our next class.